topic is limits and continuity. Already you know what is the definition of a limit? What is the definition of a limit? A function f of x is said to tend to a limit wherein if for any epsilon greater than 0, then there exists a number delta greater than 0 such that mod of f of x minus n less than epsilon. So this is the definition of a limit. But how to define a limit of a function? The German mathematician Karl Weierstrass worked on the analysis, real analysis, complex analysis, and also limits. He is also known as the father of analysis. He worked on how to define the limit as well as continuity of a function. Now, limit means it is the value which is calculated as approximate value or near value. Now, I define limit with the help of see the various types of the figures are there. Triangle, square, rhombus, trapezium, all values are there. Here the value of n is equal to 3. N represents the number of sides. N is 3. In the second figure, 4. Third figure, pentagon, 5. Sixth one, hexagon, 7 as well as n equal to 8. Now, with respect to these figures, the area increases. Correct? The area increases so that the limit, with the help of the limit, we can define as limit of the area of polygon is equal to the area of the circle. That is approximately equal to the area of the polygon is equal to the area of the circle. So that this can be represented in the form of limit f of x as x tending to c, which means the value of x is nearly equal to c, then that is denoted as n. Now, according to the definition, see here, already you know what is the definition of a limit. Now, consider this. Take this. Now, symbolically the representation of limit is in the form of limit an as tending to infinity. This is equal to limit bn as tending to infinity. With the help of the counter example, if we will take the function in the form of y equal to f of x, and f of x can be denoted x square minus 1 divided by x minus 1, where the value of x is not equal to 1. If the value of x is not equal to 1, implies what? The value of x is greater than 1 or it may be less than 1. Correct? See here, on the real axis, if 0, the value of x is equal to 1, which means the value of x is exactly equal to 1. If it is not equal to 1 means the value of x is greater than 1 or the value of x is less than 1 and it is not exactly equal to 1. So in that case, suppose for example, if f of x is equal to x plus 1, if f of x is equal to x plus 1, the value of x is 1, then what is f of 1? 2. Then we will consider the values. If value of x is equal to 0.9, what is the value of f of x? 1.1. If 1.9, correct? If the value of x is equal to 0.999, then f of x becomes what? 1.99. Similarly, another case is if the value of x is equal to, what's the value of x? 1.1. Then what is f of x? 2.1. If x is equal to 1.0001, then what is f of x? Yes, f of x is 2.00001. In both the cases, see, in this case also 1.9999 means which is nearer, approximately equal to 2, but not exactly equal to 2. And here also the value of f of x becomes 2.00001, which means in this case also the value is nearly equal to 2, but not exactly equal to 2. So, these comparison of values can be defined in form of limits, that is limit f of x as extending to 1 is equal to, what's the value? 2. In case of f of x, the function is what? X plus 1. So, to evaluate such values, they have introduced a topic that is known as a limit. So, therefore, what's the limit of a function? The value of the limit of a function lies between, in this case, a minus epsilon, which is less than 2, correct? In this case, the value of f of x is a plus epsilon, which means greater than a. The value of a is greater than a plus epsilon as well as a minus epsilon, but the value of a is equal to 1. 1, in this case 0.999, which is nearer to 1, and in this case 1.999, which is also nearer to 1. Correct? So therefore, limit of a function is, a function f of x is set to tend to a limit L if for any epsilon greater than 0, then there exists a number delta greater than 0 such that mod of f of x minus L is less than epsilon. Now, already I explained, the values can be taken in the form of a table. See here, x value 0.9, 0.99, 0.999, so on, so that the value of f of x becomes 1.999 and mod of f of x minus 2 becomes the value like this. This becomes the epsilon value. The difference of the limit as well as the table, it becomes what? 0.001, that is the value of epsilon. In this case, second table, f of x is greater than 1, that is 1.0. In this case, the value of x is less than 1. In the table 2, the value of x is greater than 1. Right? So that f of x becomes 2.001. Here 1.999 and in this case 2.0001. In the first case, it is slightly less than 2. In the second place, slightly greater than 2. So that the limit is in the form of f of x minus L less than epsilon. So that the value of this is 0 less than mod of x minus a less than this. After that, the limit can be classified into two forms. The first one is left hand limit and second one is right hand limit. What is the definition of left hand limit? A function f of x is said to have a left hand limit as x tends to a if for every epsilon greater than 0, however small there exists a positive real number delta such that mod of f of x minus n less than epsilon whenever the value of a minus delta less than x less than a. Can you define the right hand limit? Yes, define. Karthik, what's the definition of right hand limit?
Function f of x is said to have a right hand limit as x tends to a for any epsilon greater than 0. However, smaller there exists a positive real number delta such that mod of f of x minus l is less than epsilon for x is less than a plus delta. A plus a is less than
a less than x less than a plus delta. In the right hand limit, a minus delta less than x less than a. Correct? In the right hand limit, a less than x less than a plus